Hi, I'm Sean Farkas, a development lead on the .NET team. In this video, I'm going to show you .NET First, I'll talk about what .NET is. We'll walk through enabling the .NET compilers for your application and the performance wins that you may see as a result. To start with, let's talk a little bit about what .NET is. Essentially, .NET is a compiler which enables compiling your .NET code through the Visual C++ optimizer directly to native code. .NET is designed to work with the existing .NET language features and libraries you are already productively writing code against. This means, for instance, link expressions, XAML data binding, reflection invocation are all supported by .NET. At runtime, .NET apps run against a refactored CLR and framework. This refactored framework is small enough to be deployed along with your app package, meaning that if your app is not dependent on a system-wide .NET Framework components, which may be different on your customers' machines than they are on your developers' machines. Let's talk a bit about how .NET fits into the build of your application. A good way to think of .NET is as an optimization step that applies to .NET binaries. This means the first step of compiling your application is to compile your source code through the same .NET compiler you've always used, CSC for C# and VBC for Visual Basic, to produce an MSIL executable which, if you ran it, would execute against a traditional .NET framework. .NET will then compile this MSIL executable, doing things like generating code for interop and serialization and producing native code using the Visual C++ optimizer. This new app now contains native code that runs with the refactored .NET runtime and libraries. Visual Studio combines both the MSIL and .NET parts of compilation together for you, automatically running .NET compilers on your code if the Compile with .NET toolchain option is selected on your project. Once you've built your application with .NET there are several performance benefits that you can expect to see. Both cold and warm startup costs will be reduced. Additionally, the working set of your application will be smaller since you no longer need to pull the full .NET framework into your process's memory. When we ran Wordament through the .NET compilers, we found its cold startup time improved by 39%, its warm startup time by 31%, and its working set by 12%. This already represents a substantial improvement, but it makes it even more impressive when you realize the baseline for comparison is the NGen version of Wordament, and these numbers are not inflated by the time it takes to JIT Wordament startup code. Now, let's take a look at .NET in action. So we have here some standard C# code to do a physics demo. C# code would build and run successfully against the standard .NET framework. But .NET is able to apply additional optimizations. We can build for .NET by going to the project properties and checking the Compile with .NET toolchain. This will now cause the project to be built with .NET. The Visual C++ optimizer is going to notice that this code here is very parallelizable and will actually introduce vector math instructions to make it work even faster. In order to show that, let's run the two demonstrations side by side. On the left, we have the .NET version of the application, and on the right, we have the .NET version of the same code. You can see the .NET version is running nearly 4 times as fast because of the auto-vectorization optimization that the C++ optimizer was able to apply to the back end. Hopefully, you've gotten interested in .NET compilation for your app. Currently, .NET is available for Windows Store and Windows Phone apps. If you'd like to find out more about .NET or ask a question in the forums, you can visit our website. Alternately, if you'd like to contact us via email, you can reach us at .NETnative@microsoft.com. Thanks for watching.